area volume. So let's say I give you a little picture like this. Let's say that's f of x, and that's g of x, and I want to find out. So, let's say this is they cross at -1. I want to figure it out until they go to, let's say, x equals 3. Right. So if I wanted the area of this, area form is very straightforward. You just integrate the limits, in this case -1 and 3, of the top equation minus the bottom equation. Right, so in this case it'll be f minus g. And again, if they give it to you, if they give you f and g, just write that and you're good. Put in your calculator, get an answer. If I want the volume, so volume, now there's two types of volumes. There's when you rotate it around something, like in this case, let's say around x-axis. This is around x-axis. And then when you do a cross-section, perpendicular cross-section, they're very different formulas. Cross-section is the more straightforward. Just integrate the area formula. That's it. There's no pi, nothing special. Whatever the area formula happens to be, you just integrate that guy. So integrate the area formula, whatever area formula happens to be. And there's lots of formulas we talked about with that. Forgot the L, by the way. There could be a square. That means your formula is s squared. It could be a rectangle. That's base times height. The key thing, they have to give you the height. They'll say something about the height. They'll say it's like twice the base, or they'll tell you the height is 6 or something. They could say equilateral triangle. And that is rad 3 over 4 s squared. They could say isosceles triangle. That is 1/2 s squared. And they could do a quarter circle. So that's a fourth of a circle, so 1/4 pi r squared, s squared, because r is r. And then probably the trickiest one, they could do a semicircle. So that is 1/2 a circle, 1/2 pi r squared, but the r is 1/2 of s. And again, why is that? That's the trickiest one, because you draw it. Here's my semicircle. The radius only goes halfway. It's like the whole line is s. Radius is only half of the s. Different than a quarter circle. Quarter circle, the picture is different. The picture looks like a shark fin. Your radius is your s. The same thing. But in a semicircle, the radius is half of s. So keep that in mind. So it's like 1/2 pi 1/2 s squared. That's the idea. And there's actually one more I always forget to talk about. That's where they give you the formula. So it might say, oh, area formula is like this ugliness of 1 plus sine x over 3. Then you just integrate that formula, right? So there's also when it's given to you. So that's how you do a cross section, right? It's just integrate the area formula. So whatever the area formula happens to be. So there's no pre-posed pi or anything. It's just integrate the area formula. And then the other one is when you rotate around something. That's the one that has a pi in it. So when it's rotated, you're spinning it around something. That's where you have pi. So it's pi integral of whatever your limits are. I guess in this case 1 to 3 of the. I like to say the big squared minus the small squared. Oh, the big radius minus the small radius. In this case, and how you find each radius is top minus bottom still. So if I was rotating it across the x-axis, this is, I consider this the big one. And that would be top minus bottom, f of x minus 0. And this would be considered the small one. And that would be g minus 0. So that's how you do area and volume, right? So areas is top minus bottom. Much like cross section, that's how you find your s also. By the way, yeah, s over here, guys, this top minus bottom. Just like area. It just all depends on what the formula is you're using. Volume, when you rotate it, that's the one with pi and you square them. And it's big minus small. So it's all that. Let's go over examples. So let the region be bounded by the x and y axis, or the y axis and these two figures. Find the area. So first we're going to find the area. Now I want to find the area of R. I know it's bounded by the y axis, so it's 0. This part here is the intersection. So my calculator, we have to graph it and find the intersection. I tell you right now it's gonna be 1.342681 around there. It's around there. Put in your calculator. Again, you can either store this, right? You quit and then you store, and you could label it like say A, and then all you have to do is now press A and you label it here. Or you just copy down all the digits and use that. Either way should work. So anyway, for our A, let's get 9. We're gonna integrate, right? Area. So integral of 0 to my intersection. So if you could just put a variable down here like A, as long as you label it, and then top minus bottom. So the top one looks like it's 4 minus 2x, parentheses 4 minus 2x, minus parentheses x cubed for 1 plus x squared. Then you can type that into your calculator and get an answer. Now, if you prefer not to write all that out, you can just go here and say that equals f of x, and that equals g of x. And now you can just use f of x and g of x into this. As long as you label it and let them know that's what you're doing, it's all good. So that's A. B, find the volume of solid generated when r is rotated around the x-axis. So we're going to revolve it around here, the x-axis. So for B, right, we just talked about it's going to be pi integral from 0 to A of the top equation, f of x. So I like to do big minus small, so f of x all the way to 0 squared minus the bottom equation, the small one, g of x minus 0 squared dx. Type into your calculator, get an answer. C, the region R in the base solid is the base for a solid for a cross section perpendicular to the x-axis, where x is a square. So perpendicular x-axis means it's perpendicular, so it's a normal one, and it's a square. Find the volume of the solid. So again, cross section, we're going to integrate the square formula, so s squared. That's it. It'll be from 0 to A, but that's the only form we're going to do. So all we got to do is square s. S is the same thing as area. It's just top minus bottom. It's this guy. Hopefully more straight than that. So I'm going to integrate 0 to A of my top minus bottom, so in this case f minus g of x squared dx. Put that into your calculator, get an answer. And that's it. It's very straightforward, right? Area is top minus bottom. Volume is big minus small, where it has top and bottom inside of it. And then cross sections is integral area formula. That's it. Let's do another one. Let R the region enclosed by the graphs of this and the vertical line 10 in the x-axis. So in this one, I'm going to try to do a little sketch first. So let's sketch over here. X minus 1, that means it starts right here at 1. 1 to the right, it's a square root. And then the vertical line x equals 10. So remember, vertical line x equals 10 is 10 vertical line. X equals always a vertical line. So we're trying to find this spot right there, where this is y equals square root of x minus 1. Again, I'm just going to label that like f of x. It's so much easier. Just let them know you're doing it though. So we have that. A, find the area. So we're going to integrate from 1 to 10 of f of x. And there you go. Top minus bottom is going to there, so 0. Done. Again, put that in your calculator answer. B, find the volume of the solid rotated revolved around the horizontal line y equals 3. Oh, so now we're revolving around y equals 3. So 1, 2, 3 is probably over here. Now it's interesting. So we're doing pi. We're going from 1 to 10. Now again, we're rotating it across y equals 3. So I like to do big minus small. So we do the big one first. Start here, the bigger one. We're going all the way to this guy. So that's going to be 3 minus 0 squared minus the smaller one, the smaller radius. So here to here, that's a smaller one. That'll be 3 minus f of x squared. Type that into your calculator, get an answer. Now again, you can either leave it with the pi, like something pi, or you can leave it just decimals. Either way is fine. Again, but do not reduce. Do not round. Just leave as many decimals as you can. Let them don't worry about it. C. Volume generated solid when it's volume of solid generated when R revolves around the x equals 10 line. Oof. So we're going that way. So let me rewrite this. Let me draw it real quick because it's too messy. So we're revolving it left and right. So that means I got to put it, so we're revolving around the y-axis. So I got to change up my stuff here. So first, still big minus small. So now we're going to go right to left. This guy, I got to change my equation. It was this. But we're revolving it left and right, so I got to change it. Let's solve for y. Solve for x, I should say. So y squared equals x minus 1. So add the 1, I get y squared plus 1 equals x. So this is y squared plus 1. Now we're going to go right minus left. Now we're revolving around this guy. So my 10 here is my right. And we'll go to my left, which is this equation right there. So there's only one r here, right? So I'm starting from right there, going right there. So remember, right minus left. So my equation is going to be 10 minus parentheses y squared plus 1. All right, I can't use f of x because f of x was when it was in terms of x. This is in terms of y. So I'm just going to rewrite it. Keep in mind, put parentheses. And then we're going to square it, right? Because it's volume. So right minus left, top minus big minus little, right minus left. My limits, don't forget the pi by the way. My limits are going, so now again, we're going this way. So I'm starting at 0. And I got to find out where they intersect. So I didn't do that earlier because I didn't need it. But now I kind of do. Easy way, just plug it in. My x is 10, just plug it into right here. So y equals square root of 10 minus 1. So y equals square root of 9. So 3. That is 3. So we're going from 0 to 3 on my y. Plug that into your calculator. If you're wondering how you plug in a y, you don't. Just use an x. It's the same thing. So in the calculator. Because all you're trying to do is find the value. So plug into your calculator, get an answer, and you're done. Let's do one last one. So for this one here, f of x is this monstrosity, g of x is that one. So there's f and there's g. Step 1, find the area of r. So I gotta find the area of r. So we're gonna integrate from 0. I gotta find the intersection. So on your calculator, you graph both of these and find out where they cross. If you were to do that, you would get 0.17821. Now again, you could write it all like that, or you could set equal. You could store it and save it as like a or something. And as long as you state it, you can use it for the rest of the problem. As long as you state it, you can use it for the rest of the problem. So we're gonna integrate from 0 to a. And just r, the top is g. So I'm going to put g of x minus f of x. Again, we're just finding r. So there's a. Again, put in your calculator, get an answer, but that's the idea. B, find the area of s. Well, now s, it changes, right? It's from there to where they intersect again. So you got to find that point also. So again, do it in your calculator, find out where they intersect the second time. If you do that, you actually get it equals, it's at 1 it crosses. So I don't need to store that. It's just 1. So we're good there. So for the second one, again, we want to find the area. So we're going to integrate from a all the way to 1. In this case, we switch it. F is on top, g is on the bottom. So f of x minus g of x dx. And then put in your calculator, get an answer. Remember, do not round the answer. Don't truncate it. Just write it all out. They'll do it for you. And then let's talk about C. C is going to be interesting. So find the volume of the solid generated when S is revolving around the horizontal line y equals -1. So y equals -1. It's a horizontal line. They're telling you horizontal line. So let's say this is -1 so I don't hit that. So here's the line y equals -1. All right, so I got to find the volume of this guy. So first thing I hope you notice is that we're going to have two separate integrals. We have one for the r side, one for the s side. They're trying to set you up right there. So now remember, we're doing volume, so it's big minus small. So I need the big R, which is going to be from here all the way down to here. And that would be big R. Top minus bottom, that's going to be g of x minus -1. And then the small r would be f of x minus -1. So my first integral, just like my first area there, I'm going to go pi, because we're revolving it, 0 to a of my big one, g of x minus -1, or g of x plus 1 if you want, squared minus my small a, so f of x minus -1, or again plus 1. That's the first integral. Then I got to add my second integral for s. Similar idea. Now for s, you can go big minus small. So here's my big R. And that is f of x minus -1 or plus 1. And my small one would be this guy, which would be g of x minus -1. So this one's going to be from, just like what we did up here, a to 1 big minus small squared dx. Plug that into your calculator, get an answer, and then you're all done with area and volume.